Welcome back to Generative AI 101, the podcast where we take the tangled web of artificial intelligence and turn it into a delightful experience for your brain. I'm Emily Laird, your guide through this digital wonderland. Today, we're getting into the nitty-gritty of how large language models are trained. Hold on to your hats, folks, because this is going to be one wild ride through the world of AI training. Welcome to Generative AI 101. All right, let's get started. Picture this. Training a large language model is a bit like training a very ambitious, overachieving student who wants to ace every subject under the sun. But instead of textbooks, we're feeding it the entire internet. Not just any old internet junk. Think books, academic papers, Wikipedia, social media, and even code repositories. If it's text, it's fair game. Now, before you start imagining a robot hunched over a stack of books, let's talk about data collection. These models chow down on data sets that are hundreds of gigabytes and even terabytes in size. Imagine trying to read every book in the Library of Congress while also keeping up with the latest tweets and Reddit threads. That's what we're dealing with here. But it's not just about gobbling up data. No. We've got to clean it up too. Think of it like preparing a gourmet meal. You don't want any rotten tomatoes in your salad. We remove spam, duplicates, and low-quality content. Then we chop it all up. This is called tokenization, if you remember from our previous episodes, where we break the text into smaller units like words or subwords. It's like slicing and dicing your ingredients to get everything ready for cooking. Once our data is all prepped, we move on to the model architecture. Most modern large language models use transformer architectures. Now, don't think of Optimus Prime. Michael Bay exit stage left, though that would be kind of cool. Transformers in AI are all about self-attention mechanisms. Picture a very attentive student who remembers everything they've read and can reference it perfectly at the right time. This self-attention helps the model understand and generate text that's coherent and contextually relevant. Training these models is where things get really intense. The objective is usually to predict the next word in a sentence given the previous word. It's like playing a massive game of predictive text, but way more advanced than what's on your phone. And to do this, we need some serious hardware. Powerful GPUs or TPUs often working in large clusters. It's like having an army of supercomputers all working together to teach this eager student. We use techniques like distributed training, where we spread the workload across multiple devices, and mixed precision training, which saves memory without sacrificing performance. It's like multitasking on steroids. And then there's gradient accumulation, which helps create a larger effective batch size. If you're thinking this sounds like cooking up a storm in a high-tech kitchen, you're not far off. But of course, it's not all smooth sailing. There are some hefty challenges along the way. Training these models requires enormous computational resources. It's like trying to power a small city with your kitchen blender. It's just not going to happen. We also need to ensure our data is diverse and high quality to avoid any biases. And then there's the ethical side of things, making sure these models are used responsibly and don't go off the rails. After the initial training, we often fine-tune these models for specific tasks or domains. Think of it like sending our star student to a specialized boot camp to master a particular skill. Whether it's understanding medical text or drafting legal documents, this fine-tuning makes the model even more capable. That's all for today's exploration of training large language models. If you've got questions, thoughts, or just want to connect, you can find me on LinkedIn. Just look up Emily Laird, Laird, and let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about training large language models now than you did when you arrived.